So now that we know if the point AB is on the graph of f, that the point BA has to be on the graph of f inverse, we're ready to check out example 2. So in example 2, the statement is that they have given us the graph of a one-to-one function. And when you look at those words, you have to think about, why did they tell us that f is 1-to-1? Remember once again that if f is 1-to-1, then it's going to have an inverse function. So we know that this is going to pass the horizontal line test because it is 1-to-1, and you can double check, and yes, it does pass the horizontal line test. So now that we know this, then the question is asking us to draw the graph of f inverse. Well, okay, so if you think about what we just talked about, any point on f has to have a friend on the graph of f inverse. And what you do is you take the x and the y coordinate and you interchange them, you swap them. So when you look at the point -2, -5 that's on the graph of f, that means then that the point -5, -2 has to be on the graph of f inverse. So -5, -2 is going to be right here. And what I'm now going to do is the same thing with the rest of these points. So -1, -3 is on the graph of f, so that means that -3, -1 has to be on the graph of f inverse. -3, -1 is going to be right there. And then 1, -2 is going to have a friend of -2, 1 if we interchange the x and the y coordinates. -2, 1 is right here. Now, sometimes people have a little bit of a problem with this last one because it is simpler than the other ones. So the point 2, 2, and as you interchange the x's and the y's, it simply comes to 2 to 2 again. So on the graph of f inverse, we also have 2, 2. So now that we have all of these special points, we can connect the dots, just like we have over here for f. So let's go ahead and connect the dots for f inverse. And now as you connect those dots, there's something special to notice. When you look at the graph of f inverse up here and the graph of f down here, notice that we have a mirror image going on. F and f inverse have that mirror image behavior, but it's not one of the mirror images that we've seen before. We've seen the idea of symmetry with respect to the x-axis, we've seen symmetry with respect to the y-axis, and we've seen symmetry with respect to the origin. This is a new kind of symmetry. This symmetry is symmetry with respect to the line y equals x. But it has the same kind of behaviors. Y equals x, we have this cutting our graph in half, and we have the mirror image on the two sides. On one side we have the graph of f, on the other side we have the graph of f inverse. So that's worth writing down. The graph of f and the graph of f inverse are, and then let's fill in the blank, symmetric with respect to the line y equals x.